Well, now it's about the results. So how, within this analytical scheme for the determination of mycotoxin, can I report my result? And you see here an intercomparison study which was carried out in 1998, so a long time ago, for the determination of zearalenone in maize. And you see here the mean value of all the participating laboratories, which is around 73 microgram per kilogram. And you can see here certainly coded, so this was certainly the participants were not revealed. We see here the individual mean values and their uncertainty reported, and these values ranged from about 14 microgram per kilogram up to 140 microgram per kilogram. So that was certainly unacceptable, because they knew right away that the level will be somewhere between 10 and 500 microgram per kilogram. So I think you would possibly get the same result by just randomly picking any number between these range, and you will possibly get a similar result. So the CV, the coefficient variation was plus minus 40.5%. No common calibrant was provided here, so each lab also used its own calibrant, and that actually also contributed to this result, which was not very satisfactory. I'm going to skip that part. We have already talked about recovery and uncertainty, that this is an important part. So definitely one has to mention, calculate the recovery, and also to calculate the uncertainty in order to get comparable results. What I've not mentioned before is that there's an email address for those of you actually who would like to calculate the uncertainty of their measurement result. There's a Eurocamp guide quantifying the uncertainty in analytical measurement, which you can use in order to calculate measurement uncertainties. Within the concept of measurement uncertainty, within the concept of traceability of your results, it is very important to have certified reference materials and proper quality assurance in place. I quote here from the FAO-WHO report by JECFA, the Joint Expert Committee on Food Additives, that an analytical quality assurance system should include, when possible, systematic use of reference materials, or ideally certified reference materials, which are accompanied by a certificate, and also regular participation in interlaboratory comparison studies, in order to be able to demonstrate comparability and that your results are not prone to any type of systematic error. Nowadays there are 12 certified reference materials for 6 mycotoxins available, mainly through the IRMM, the Institute for Reference Materials and Measurements in Yale, but also for FACBAS in York. So you've got aflatoxins in milk powder as a calibrant in peanut butter. We've got ochratoxin A in wheat, DON in maize and wheat, zearalenone in maize, zearalenone calibrants, and also DON and nivalenol calibrants. By the way, these group of DON and zearalenone certified reference materials have been produced by the Center for Analytical Chemistry. That was my early work 10 years ago, where I had the pleasure to coordinate 2 European Commission funded projects to that particular topic. So how does a certificate which accompanies a certified reference material look like? So we've got a compound here, zearalenone, estrogenic mycotoxin. We've got a certified value of 83 microgram per kilogram, an uncertainty of 9 microgram per kilogram, which corresponds to the expanded uncertainty within a confidence level of 95%. We had 18 laboratories participating here, contributing to this mean value, this certified value. But this uncertainty does also take into account, by the way, not only the uncertainty of the measurement, but also long-term stability of the material, because they want to sell this material also in 10 years from now, and they have to demonstrate the stability, but also in case of slight instability, so what is the contribution of potential instabilities to the uncertainty of these results.